Scientist, it's your favorite sensei here, Sensei Mohau, and it's good to be back. Today on this lesson we are going to be answering questions from last year 2025 June exam paper from Gauteng. So on this lesson I'll be teaching you how to tackle one of the most hardest questions that you can ever find in sequences, series and patterns. So I hope you enjoy this video. Don't forget to like, to subscribe to the channel and to share the video as much as you can. So without any further ado, let's kick in. So question 2.1 says the first three terms of an arithmetic pattern are -5 to 9, and the first question says write down the next two terms of the pattern. Easy one. So now remember, how do you know, how will you find the first two patterns in the sequence? The first thing that you have to do is that you have to now find, firstly you have to find the constant difference. You have to find for these numbers here, the add or the subtract. So basically you have to find the difference between these two terms, and we can see that it starts from the negative to the positive, which means it's increasing. So how do you do this? Easy one. We just gonna use what we always used, what we are used to from grade 9, T2 minus T1 and T3 minus T2. So it's 9. So I did it the other way around, sorry for that. 9 minus 2 equals to 2 minus 5. So it's 7 is equals to 7. But now if we know that the numbers increase by 7, so we have to go from 9, then add 7, then it's going to be 16, then 16 we add 7, it's going to be 23. So we know that the two next terms in this pattern will be equals to 16 and 23. Now let's go to another question. So now this question here says that show that the sum of the first n terms of the patterns are this. So now basically they want you to find the formula of this, basically this pattern. They want you to find the formula of the sum of this number pattern. So now remember, now the general formula of this, it's n over 2 2a plus n minus 1 d. Now remember, now grade 12, that here a, remember, it's the first term in the sequence, which here we know it's -5. Then d, it's the difference, which is 7, +7. So now basically here, since now we know the first term and the difference, we just substitute so that we will get to this answer here. So n over 2 times 2 -5 and plus n minus 1 and 7. So now first things first, remember, let's just focus on whatever is inside the brackets first. So now it's going to be like this, it's -10 here because of it's -5 times 2, Then here, remember, we are basically doing something like this. It's factorization here, né? Although it is the 7 is put this side, it's just the same thing, just factorizing using that FOIL method, né? So it will be 7 times n and then 7 times -1 basically. So even here it's just going to be the same thing, 7 times n then 7 times -1. So it's going to be 7 times n. We know that it's going to be 7 n then -7, just like that. Now we have like terms here, so it's going to be -10, -7, it's going to be -17 because we take the sign and we add this, so it's going to be 7n minus 17, and then this is basically our final answer. You know, it's just half n and then 7 n minus 70. So let's see, it's just the same thing. Easy one, this one. Basically the gist of what you were supposed to do, it's just you have to know the first term and the difference, and then you just substitute into the general formula and then work it out from there. Easy peasy. Now let's go to question 2. Now question 2 is now we are dealing with quadratic patterns. Now on question 2, the first 4 terms of quadratic patterns are x, 3x minus 5, 4x minus 3, 5x plus 1. So now determine the value of x. How will you find the value of x? Now here is the tricky part. Remember, if this was an arithmetic sequence, let's say for example it's x and then 2x and then 3x. I'm just making an example. If this was an arithmetic sequence, this is what we were going to do. We were just going to take t2 minus t1, and then from there on it's just going to be 2x minus x, then you get the difference is x. But now, because of this is a general, it's a quadratic pattern, we know that here we have 2 constant differences, so we have to consider that before. So now let's just try it. So now we have to now make the first term difference and the second difference. Then after that, that's when we will now find the value of x. Now the first difference here, let me just take another color. Now remember, how do you find the difference? We take this subtracted by this. Remember, it's basically 3x minus 5 subtracted by x. Remember that. So now basically here, for us to find the first term, the first difference here, we know that we are just going to take this minus this and this minus this, basically. So this is just me showing you how we find the other term. So here, remember, it's the like terms here and here, so it's the first term in the first difference, it's 2x minus 5. Remember that. Let's try this one also here. Okay, let me just do it here. It's 4x minus 3 minus into minus, so it's 4 and 3, which is 3, and then this will be positive 2. Ne? So it's just gonna be 2x positive 2 just erase this. Ne? Now let's, for the next one, let me just do it here. It's 5x plus 1 minus 4x minus 3. This will be x, then 1 minus into minus, this is positive 3, so it's 1 plus 3, which is just 4. No, 1 and negative 3. Yes, it's just 4. Okay, so now we have to find another difference here. Let me just erase this here so we can find space. Now here we're just doing the same thing. To find the difference between these two, we know that it's going to be this subtracted by this. It's just x plus 2 subtracted by 2x minus 5. So it's just gonna be negative x, and then here plus 7. Same applies to here. So now on this term, difference on this 2, we got this one. Remember now, the only way we will know the constant difference is on this numbers that are on the second difference. Why am I saying that? Because remember, the numbers here on the first difference, they don't have a specific common difference because of they just escalate. Now check, now I want to show you something. Check now here. Ne? The difference between this and this, it's this one. Let's check now the difference between these two. It's x minus x plus 4, sorry, minus x plus 2. Excuse me. So now you can see now that this is going to be x plus 4 minus x minus 2. This and this are additive inverses, and the difference between these two things is just 2. See what I said? So now henceforth, the only way we will find the constant difference is when we use the second difference. So if they give you a similar solution, sorry, a similar problem in any exam, in your upcoming exams, you know, if you are given a quadratic equation, a quadratic pattern, and you have to solve for x there, the only way for you to find x is for you to know the second difference, to find the second difference. Ne? Then from the second difference, you know that you can just use the basic normal formula that we are used to, and then you find a common difference. Ne? First difference numbers, they don't have a common difference because of they just basically escalate. Ne? The difference escalates. This is basically a good example of that. Or you can see from this one to this one, they change by negative x plus 7. That from this one to this one, they change by 2. Ne? So just put that in mind. So now we have this and that. Ne? So now we know that in every quadratic equation the second difference, it's the same. Remember, it's always the same number. So basically we know that this number here and this number here and this number here are just the same, are just equal. Hence why we are just saying negative 7 plus 7 equals to 2. Then from there on we will just solve for x, and then after solving for x, then we will basically we'll be done with the question. Ne? So it will be this to the other side, it will be negative x and then negative 5 basically, because it will be 2 minus 7. And then for us to have x as a positive 1, we know that we will divide this by negative 1 and also this by negative 1. Then we will find x is equals to 5. Okay? So remember, the reason why we took this long dry method, it's because of the only possible way or possible solution for us to find the value of x is if we can find the second difference. Ne? Because we know that second difference is the same, then we can basically do it in an equation form, ne? And solve for x. We can use the other difference because of the numbers are not the same, they escalate. Ne? Just put that in mind. Ne? So we know that x is equals to 5. So basically we know that the first term in the sequence is equals to 5, and then the second term is 3 of 5 minus 5, it's 10, so it's 5, it's 10, and then it's 4 times 5 minus 3, which this one will be 20 minus 3, 70, and then 5 times 5 plus 1, it will be equals to 25 plus 1, which is 26. Ne? So we know that this is the pattern, is the quadratic pattern. It's 5, it's this, it's that, it's this. So we know that it's basically this changes by 5, 7, 9, and then 2, and then 2. Hence I said we know that this number here, everything is the same. So hence why we just know, like we just solve it for like this. Ne? This escalates, changes because of that. So now the second question says, if the pattern continues indefinitely, apologies on this, I downloaded it from stenmorephysics.com website, so you know it has that watermark of Stenmore Physics. So if the pattern continues indefinitely, prove that all terms of the pattern are positive. Now here's a trick. Remember, for us to prove that everything here is a positive, you all can see that it goes from 5, then 10, then 17, 26, then it will continue to move towards the positive. Ne? But how do we actually prove it? Ne? Remember, if we just basically, let's say we just shift these two functions, let me just choose red, it means that our graph must either be something like this, and yet it must be on the positive axis. It must be on the positive, not on the negative. Ne? So now, which means that the A must be positive, which means that the N, this N here, must be positive. Ne? Remember that. Ne? So now basically here, this is what we are supposed to be looking for. We are supposed now to find the general equation of this quadratic pattern, and to see now if this general equation of this pattern would be a positive y equation, which means it would be, let's say for example, positive 1 squared plus n plus 7, something like this. It must be positive here, which means it is basically something similar to this, that it is a graph on the positive y-axis which increases or goes towards the positive y-axis. So now we have to find the general formula of this pattern. Now remember, we have this, it's 5 here, it's 7 here, it's 9, and here it's 2 and 2. We have 2a is equals to the second term, okay? The first number in the second term, which is just 2. So to solve for a, we know it will be just 1 because we divide both sides by 2. So 3a plus b is equals to 5. So it's 3a plus b, which will be 3 plus b is equals to 5. And remember, now since we are solving for b, remember that we basically must solve for this equation here. So hence why we are solving for a, for b, for c. Remember that. So b is equals to 5 minus 3, which is equals to 2. Now for c, it will be a plus b plus c is equals to the first number in the original sequence, which is 5. So it will be 1 plus 2 plus c equals to 5. It will be 3 plus c is equals to 5. Then c will be equals to 2. Now, which means our general formula will be like this: 1n squared plus 2n plus 2. So now, because of this n here is a positive, here it has a positive coefficient, which means our graph will be a graph on the positive y-axis that is increasing. Hence why by that we can prove that all the terms are positive. So now let's continue with the next question. Question 3, now we are dealing with a geometric pattern series. Determine the value of p which the series converges. Now remember, here we are basically similar to solving for x that we did in the previous one. We can only solve for this p by finding the ratio. Now because of this is a geometric one, we have to find the ratio. If it was an arithmetic one, we have to find the constant difference. Now remember that. So just remember, each and every time they give you variables and they want you to solve for the variable, you have to either use the ratio if it's a geometric series, or the constant difference if it's a quadratic pattern. So if it's a quadratic or an arithmetic sequence. So now, how do we find p? Now we have the first one, so it's half p minus 3. It's the first term. This is the second term, 3 over p, and 4 minus p squared. So remember, how do you find the ratio? It's T2 minus T1, ne? It's T2 minus T1, sorry for that, T2 it's T2, sorry, minus T1. It's going to be 3 over 4 P minus the reason why I'm doing this, I'm expanding it because we have this one, eh? So here it will cancel out this one. Then 3 over 4 divided by half. Let's use the calculator and check. The answer is 3 over 2. It will be 3 over 2 and P. Ne? So now the only way to find the value of P, so now we have the ratio. Ne? So now remember this. Probably you still remember it. Ne? If we are dealing with converges, we have to know the ratio in this format. Ne? It must be either greater or less than 1 or negative 1. Ne? So we have to take this R and insert it here, then after that we'll solve easily for P. Ne? So let's just kick in. So it will be negative 1. Sorry for that. Negative 1 and 3 over P. Let's just factorize it in J. Yeah? Then it will be negative 9 over 2. Then this will go to the other side and also go to the other side. It will be now negative 1 plus 9 over 2. Remember it was negative, it will become positive on that side. And here it's 1, it will be positive here on this side. So now let's use the calculator and check. Negative 1 plus 9 over 2. Answer is 7 over 2. And then let's check if we add, it will be 11 over 2. Now remember, we are solving for P. Eh? So we have to divide with this coefficient here. So it will be now 11 over 2 divided by, sorry for that, divide by 3 over 2. And here 7 over 2 divide by 3 over 2. Then our final answer for P will be 11 over 3, which is 3,67, and here it will be 7 over 3, which is 2,3, and then it's here, it's 3,67 basically. Right? So we know that now they gave us this, that P is not equals to 3, therefore we know that P will not be equals to 3 but it will be within this range of these numbers, right? So that's how we tackle it. Remember, now let's recap. Because of we are solving for the value of p for which the series converges. For convergency, we have to use this formula. Now, since we are given the pattern, we have to firstly find the ratio. Then after finding the ratio, we just take that ratio and substitute it here in this formula. Then we solve for the range of p. The value of p using that convergency range. Now let's do the second one. Now, if the sum of infinity of the series is 1, then determine the value of p. Now, how do we do this? Remember now, we have this formula. For the sum of infinite, we have to, it will be a minus 1 minus r. Right? So now, we have to know the first term of the sequence. We have to know also the value of r. And then, now they told us that this sum of this infinite terms is equals to 1. Therefore, we know that it is 1 equals to, let's find the first term, it's half p minus 3. It's half p minus 3 in brackets divided by 1 minus 3 over 2 p minus 3. So now basically we have to solve for p in this problem here. So now how do we do it? So we know that now this thing is multiplied by 1. Let's do cross multiplication. We know that it will be this multiplied by this 1 and 1 multiplied by that. We know that basically we can just take this to the other side without even changing it, because of it's multiplied by just 1. So which means it will be 1 minus 2 and equals to half. Then now from here we just solve for p. Remember now here we just have to factorize those things because of we have to solve for p. So it will be 1 minus 3 over 2p my positive 9 over 2 equals to half p and then minus 3 over 2. So now like terms here that we have, I'm just going to do them in red. It's this one and this one. So it will be 1 minus 1 plus 9 over 2, which will be 1 plus 9 over 2. It will be 11 over 2. So 11 over 2. And then negative 3 over 2p. Negative 3 over 2p. It's now equals to this one. So now we can just take 3 over 2 and to the other side. Let me just do it like that. Just erase these things. So it's 11 over 2p. Remember, 11 over 2p comes from us adding these two things. 1 plus 9 over 2. And then this thing, we just take it to the side. It will be positive 3 over 2, and we will have now 14 over 2, which is just 7. And here we have half p plus 3 over 2, which is just 4 over 2p. So now, which is 7 equals to 2p, and the answer will be 3,5. So just like that, we have found the value of p, that it is equals to 3,5. So I hope you all enjoyed the video. Don't forget to like the video, to subscribe to the channel, and also share this video as much as you can. From me, your favorite sensei, it's a wrap, and peace and love. Bye bye.